So now let's look at the first exercise related to Biot-Savart's law. You can refer to your PowerPoint slide. So now you have a current filament of 10 ampere is oriented in the positive y directions, starting at this point to this point. So you have to determine the magnetic field intensity at this point. Okay, so the question asks you to find the magnetic field intensity, which means that you need to find the H. Okay, and you also need to find the H using this equation. This equation. So now let's look at how we should solve this one. Okay, so this one is the solution. So according to the question, you have a current filament. So this, the red one, the red line is the current filament. Start from 0 to 0 up to 080. Okay, so this is the line. And this is the observation point located at 061. 061. Okay, so this is the equation that you have to use. Okay, I, you have no problem because I already mentioned by the questions. So the value of the I is 10 ampere. Okay, no problem for the I. Next, okay, we have to find the R. So before we find the R, we have to draw something on the diagram. Okay, we have to draw something on the diagram. So the R is the distance between the current filament and also the observation point. So you need to connect a line. So this is the line. Okay, you need to construct a line from the current filament touch the observation point. Okay, the important point here is this line. Okay, it must form a 90 degrees here. So it must form a 90 degrees here. So if this line you draw until here, the angle will not be 90 degrees. So you have to draw a straight line so that this straight line will form a 90 degrees angle with the current filament. Okay, so we draw this straight line and we put an arrow like this. And this is actually represent the vector R. Okay, vector R. So in order to find the vector R, we have to determine the position, the location or the coordinate of this point. Okay, so this is 061. So this point will be 060. Okay, right? 060. So 060. So when you minus the observation point with the with the source point, okay, this is the point that has the current filament. When you minus them, you will get the unit vector R, which is equivalent to unit vector Z. Okay. Next is to find the magnitude. Okay. So for this thing, when you find the magnitude for this thing will be equals to 1. So your unit vector R will be equivalent to Z. Okay, so you have settled this one. The magnitude, the value is 1. Next, let's move to find the angle of alpha 2 and also alpha 1. Okay, so before you find it, you need to connect the end. Okay, the end. There are two ends here. You need to connect the end with the observation point. Okay, and if according to the coordinate, this, the value, the coordinate is 2 and this is 8. So we label this point as point A and we label this point as point B. Okay, the value here will be smaller than the value here. And the angle that is attached to point A will be alpha 1. If you remember what I mentioned in the video, alpha 1 should stay outside. That's why this one will be your alpha 1. And the alpha 2 will stay inside. Okay, so this one is your alpha 2. Okay, so you need to find the angle. So the angle, I redraw it here. Okay, so just now we know that this is 0.6, right? This is 0.6 because the coordinate is 6. So I draw this triangle here. This is 2, this is 6, and this one will be the height 1. Why it is 1? Because the Z is 1, right? So it is 1. So you need to find the alpha 1 by using this one. Okay, so if I use the tangents, it will be opposite over adjacent. So you will get your angle which is equivalent to 165.96. And now let's look at the alpha 2. So I will draw this triangle. Okay. And this is 6, this is 8. Okay, so the length will be 2 and here the length will be 1. Okay. Again, I use the tangents. Okay, the angle will be 26.57. Okay, next is to find this one. Okay, is to find this one. So this one is equals to the direction of the current, and this one is the direction of the unit vector R that you have calculated. Okay, so let's look at the current filament. So the current is flow in the positive Y direction, and your unit vector R is equivalent to Z. Okay, equivalent to Z. So you put Y cross product with Z. So you might need this diagram to assist you. You put the X, Y, Z here. Okay, if Y cross product with Z, you are in the correct flow, right? So you will get the positive X direction. So you insert the value that you have. Okay, here you insert it. Then you will find that the magnetic field is this value in the X direction.